This is another edition of 3D printing news Unpeeled, courtesy of 3dprint.com. So today we've got a couple of news items for you. The first one is that Lynxter is releasing a new silicone 3D printer. So Lynxter, is a French company. They make 3D printers for industry, and they have material extrusion printers that work on filament. And you could usually then take the nozzle, swap it out for a one-component liquid nozzle that deposits liquid, or a two-component mixing nozzle. These mixing nozzles allow Lynxter and other firms, such as Delta Tower, other companies making these printers, allow these firms to make a two-component or one-component silicone or polyurethane or other materials. And now this, of course, really expands our material offering. And in this case, Lynxter's new printer is meant to be able to, in an industrial way, produce these silicone parts, either for medical or for near medical uses, let's say, or in industry generally. And this is a great step forward. We have traditionally been very, very limited in the way of making flexible components, especially flexible components that are very UV resistant for a long time, and also flexible components that have to last a long time. We've really, really been very limited in that. And Lynxter and its competitors could really bring us a lot closer to this as well. Arberg has a system that does something like that, similar to this, and there's a couple of other players playing in this area. But generally, on the whole, anything that's good for these guys is great for us because it can really expand our market. Now, think just about, for example, one application. These silicone dental aligners, clear dental aligners, right? These are 3D printed indirectly, right? You make the mold or in stereolithography, and then they thermoset it to make the final product. That is perhaps maybe per day is 500,000 3D prints every day, not only Invisalign, but other clear dental aligner companies together. That's 500,000 3D prints. One of the largest, if not the single largest application for 3D printing as one dental product. Right now, I don't know if these types of printers can be used for these kind of clear dental liners at this point. No, I would say not. But imagine they unlock a similar kind of application in the future. It could be huge. And so I think it's fantastic. Now, the other thing that Lynxter has announced is that they now have a support material available for this process. So far, there's no support available for these liquid silicone one-component or two-component processes. So that's a great news that they can have a support material. Elchem, which is a chemistry company that makes silicone for 3D printing, announced recently that it has a support material for liquid silicone printing or liquid additive manufacturing, or lots of different, it's known by lots of different names, let's say. Essentially, essentially the process, you have one mixing nozzle that extrudes this, and then usually the mixing nozzle is by a German company called Viscotech, and they mix it accurately and they dose it accurately as a dosage nozzle, let's say, to mix it, and then the part gets printed. But of course, without support, you're very, very limited in this kind of way. So Elchem has announced that it has a support material, and now Lynxter has announced that it has a support material. So either Lynxter is using the Elchem material, which may be the case, which is good, or another vendor is also introducing a support for silicone printing material, which is even better for all of us. So that's both of that is wonderful. So they have an RTV2 silicone, which has skin contact approval, which would be really great because a lot of the applications think of masks or think of masks for welding or diving or all sorts of masks, right? Or sports masks or equipment, things like that. Or think of things like braces, orthopedics or orthotics. So that skin contact approval is going to be really, really very important for this kind of stuff. They have that material available for shore hardness A5 to A40. They also have a polyurethane material available and other silicone type, more industrial materials without the skin contact approval. So I think this part of the people, but it gives a accuratized material extrusion printer the ability to print silicones. This is a really cutting edge material for us. So I think this is a part of the market that needs to be studied more, and I would love to see more products in this part of the market. There's Spectraplast, of course, which is a different product to make silicone. But, they're out there kind of alone. It'd be nice to see a lot of people compete with them and have a lot of solutions for silicone. The next news it was a bit unexpected. I think actually this news came out about a year ago, and then the Kistler group said that it had released a typical type of temperature and pressure sensor. And now they're actually bringing it on the market. Kistler Group is in Switzerland, and they've released a miniature piezoresistive melts pressure sensor. Now, these type of things have traditionally been employed in the plastic extrusion industry. So the people that make filament or fishing wire or whatever, any kind of like, or a mixed plastic, like compounding companies and things like that. They also operate extruders. They're much larger than the ones we operate typically. And these guys are used to using these melt pressure sensors to measure all the effects going on in the melt zone. Now what they've done is they made a 3 millimeter diameter front end sensor, which can take measurements directly inside the extruder or near it or in it, physically in it. This is called the 404A. It measures both pressure and temperature in direct contact with the melt zone or the melt pool. And they've actually said that it's also suitable for additive manufacturing. They have a 1,000 bar version, which is specifically meant to cater to additive manufacturing. So they're really looking at our market, which I think is wonderful. It can work in temperatures up to 350 C, which means for us, it's nearly all the materials we extrude up until ASA, and maybe with a little luck, your polyamides. And I think this is absolutely fantastic development. I think we are now printing blind, right? If we're talking about material extrusion, we're sending a filament through an extruder. Now, this filament could vary in thickness, it can vary in diameter, it can vary in the actual speed and pressure that is being applied to it. And inside the melt zone, or you can have wall slip effects, or you can all sorts of effects and pressure buildup there. And we're flying blind, right? We don't exactly know how much filament we're sending through at any time. Well, there's people trying to solve that. And we don't exactly know what the exact temperature is when we're extruding it. So any kind of more precise control over that would be absolutely fantastic. And, imagine then we could more accurately deposit material at the right time, at the right moment, more accurately ensure the flow, more accurately kind of like, for example, increase the temperature a little bit because we know we have more material or that kind of thing. That could really, really improve print. Now, obviously, this is probably going to be the type of thing that we're going to see on large format extruder, pellet extrusion type systems. We're going to see it maybe on medium format systems, but I'd love to see something similar to this, maybe a much cheaper one or even smaller. I'd love to see something like this function inside of like every material extrusion printer. I think this would really, really improve our results to an unimaginable degree. And I hope that the Kistler Group or other companies like it will make many, many of these available to 3D printing. The next thing is that a metal 3D printer has been installed in the USS Bataan. So metal 3D printers, 3D printers are afloat in the US Navy on a number of ships, right? There have been metal 3D printers temporarily installed on a number of ships as well as a test. And now a printer is going to be installed like permanently on a ship. And this is from the Commander Naval Surface Force Atlantic. And we're here together with Naval Sea Systems Command Technology Officer, NAVSEA Technology. And the system that is being installed is one that exists and may be a little bit under the radar for you and should not be, especially thanks to this news. It's a Philips additive hybrid system. So what the guys, Philips, well, who's Philips? Like Philips this is not the Dutch, let's say, medical group at the moment. This is the company that used to make light bulbs. This is not them. This is Philips Corporation. This is an American, really large kind of technology integrator, technology company that works for a lot of government clients, defense, a lot of industrial clients, and lots and lots of places worldwide. So they have the expertise in making technology available for the government. And what they did is they put a Haas, they took a Haas TM1 CNC mill, right? Which is a very well-known American company that makes a lot of VNC, vertical machining centers and CNC equipment. And they put a Meltio 3D print head in it. So what's a Meltio 3D print head? Meltio is a Spanish company that make a head with a bunch of lasers in it, and they have a laser wire deposition kind of print technology. It's really robust, and it's easy to install in all sorts of systems. And they're also open to you. They make a printer. You can buy a printer for them. But they're also open for you taking this print head you see in front of you right now and then installing it on, for example, a robot arm, or in this case, this Haas vertical machining center, or CNC mill, sorry. The one thing that I really think is, obviously, Meltio, a Spanish startup, would have never gotten the sale without, of course, working with these Philips guys, right? And the Philips guys would really, have the expertise to support the government in this kind of thing and have the expertise to work with the U.S. government. Also, what also is a good news, of course, Haas sells a system, which is essentially a 3D printer, but Haas doesn't have to make the 3D printer. Also wonderful for Haas, right? Now, but there's another beautiful thing going on here. That is that the fact that the Navy has a number of Haas TM1 CNC mills afloat already. They're aboard aircraft carriers, right? So it's familiar with the system, right? Part of the functioning of it, the safety of it, the fact that they don't catch fire, all that kind of stuff. They're already confident in that. So actually, in this case, the fact that Haas and Phillips are selling this thing promotes the confidence of the Navy in actually putting this technology aboard their ship. So it's a beautiful story of integration, a beautiful story about how being open to having other people repurpose your technology is a great thing here. So the Bataan is a Wasp class multi-purpose amphibious assault ship, right? About 2,500 people on board when it's all good and underway. And it is going to be 3D printing parts out of 316L steel, which is a very popular material also for the Navy. And it's going to be doing this in this additive subtractive manner. So the Meltio printhead is a laser metal deposition, a wire laser metal deposition printhead. Now, the wire here is really important because it means there's no powder, which means it's much cheaper. But, and crucially, of course, for being aboard a ship, it means it's much less likely to, it's not going to explode like powder might in handling or in the machine, or it might not, or it could catch fire. So it's much, much safer, which of course for the Navy is very important. But like stated, it's also really, really cheap. So this makes a near net shape part, and then the Haas machine will then mill it down to make it nice and smooth again. So this can make parts that are like in the tens or maybe $100 or whatever, instead of thousands of dollars like some of the other systems, which also makes it very suitable from a cost picture. The potential for this kind of thing in the U.S. Navy is incredibly large, right? Some navies have gone on the record saying that at any one point, half of their fleet is in dock or being refurbished or being repaired in some kind of way. Right? The United States Navy alone spends tens of billions of dollars on repair. And any kind of sustainment and operations it can do to lengthen the stay of a ship or lengthen its time at sea or to make some improvised repair is of course being hugely beneficial for them. Now, in peacetime alone, they could save a lot of money doing this. And it will keep things afloat. Now, in wartime, of course, when things are breaking all the time and there might be catastrophic damage aboard a ship and we might need to have parts where we're in the middle of nowhere somewhere, of course, the Navy, the disadvantage will be magnified. This is the potential just only for this naval application is gigantic, right? And then on top of that, there's also all sorts of other ships and super tankers and oil platforms, all sorts of other stuff. And NAVSEA has been doing a ton of work on doing this. They have 300 or over 300 AM technical data packages. The idea behind that is that they have an additive manufacturing, what they call as data package, and that's kind of like a procedure / settings to make it printable on the technologies that they support. So they want to ensure that with all the clunky software infrastructure we have, that they can print these parts to spec. And that's taken them a lot of work. But the Navy also, thanks to NAVSEA and others, has 3D printers aboard 8 ships and 4 submarines, right? So imagine this: 3D printers aboard submarines, right? And so far they've printed over 4,000 parts, right? And they have, comparatively few, about 50 sailors trained in 3D printing, which is not a lot, I don't think. Great career opportunity, by the way. They also have 96 national stock, or NSN. This is like the NATO stock number. This is like the US one. It's like that means that their 96 parts are officially stock numbered parts that are just officially standard parts. And the Navy's working on essentially FDM, right? DD, powder bed fusion, and also meld, right? Or meld, well, friction stir, but that's probably going to mean meld. But it could mean other people as well. So I think they're doing really, really great work. And this could be a huge opportunity for Haas and Meltio and also for 3D printing to help these guys get underway and keep underway and help repair ships underway generally. So all around, a lot of exciting news today. I hope you enjoy this. I hope this is useful for you. My name is USS Peels, and this is 3D Printing News Unpeeled.